Hello guys, welcome back to Math Zone African Motives, still working on our O-level mathematics, and this is the simplification part whereby we are going to be working with addition and subtraction of our number bases, just like what we had in our normal simplification, the conversion of our number bases. This time we shall be talking about the simplification in terms of addition and subtraction. So if you consider number bases, it is important that you understand how to add and also how to subtract. So the first thing that you need to understand on your addition and subtraction is that we can only do this when we are considering the same bases. Our addition and subtraction is supposed to be taken when we are working with the same bases. And also just a basic of your understanding. Remember, I was saying from our number bases, when we are working with the base of 3, it means the numbers that we are supposed to have in the base of 3 are supposed to be less than the base of 3. It is impossible for us to have the base of 3 in base of 3 or a number that is more than this base of 3 in the base of what? In the base of 3. So meaning to say the numbers that we expect to have in the base of 3 are those numbers that are less than 3. All right, let's consider addition. When we are given to add our numbers, let's say we have got two numbers. We've got 1, 4, 3, that is in the base of 5, and we are adding 4, 4, that is in the base of 5. Take note, the bases here are the same. So it means our addition is possible. It is possible for us to add. So how do we add? That is the question. So if you consider this, we are going to add our numbers just like normal numbers, 3 plus a 4. What are we obtaining? We are obtaining a 7. Remember what I was saying, in the base of 3, we are supposed to have the numbers that are less than 3. So meaning to say in the base of 5, we are supposed to have our numbers that are less than the best, which is the base of what? The base of 5. So it is impossible for us to write 7 base of 5 like that because 7 is bigger than the base. So what are we going to do? In the case that the base is equal to the base that you're given, the answer that you're obtaining here is equal to the base or is more than that base, you divide the number by the base. This is the number that you're obtaining, which is 7. So we are going to divide this 7 by the base. You divide by the base, which is by the base of 5. Noting the remainder. So that is 5 into 7. It is going to be what? That will be 1. And we've got a remainder there of what? Of 2. So take note, you are going to write the remainder on your answer. Remember, even when we're dividing that condition of our conversion from base 10 to base 5, you were noting the remainders on your answers. It is the same case. The remainder is the one that you are writing on the answer here, meaning to say you are obtaining a remainder of what? A remainder of 2. We are in the base of 5. It's possible for us to write a 2 in base of 5. It is less than the base. What is going to happen with this one? We are going to carry this one to the next numbers that you're given. So you're going to give a 1 there. Meaning to say we are now adding 4 plus 4 plus 1, which is 4 plus 4, that is 8, plus a 1, which is now 9. 9 is bigger than the base. So it's impossible for us to write the 9 there because it's more than the base. We have to divide. 9, our base, divided by what? 9, the number that we obtained, divided by what? By the base of 5. So that is 5 into 9, that is going to be 1. And we've got a remainder of what? If we divide properly, we get a remainder of 4. So the remainder is the one that you're going to write on your answer here. Then what about this one? We are going to carry it to the next term. 1 plus 1, that is going to give us 2. So we have got 2, 4, 2 in base of what? In base of 5. So this is how we simplify our numbers. If we are dealing with addition of the number bases, we are simply maintaining that concept that the base or the numbers that we are supposed to have should be less than the given base. 2, 4, 2. These numbers that we see, they are less than the base that you are given, which is the base of what? Which is the base of 5. So this is what you're expected to do. In these calculations that we are given here, we are asked to simplify the first part number 1a, to simplify, we've got the first part a, that is a 1, 1, 0, 1, 1 in base of 2. And what are we adding? We are adding this, which is that is a 1, 0, 1, 1 in the base of 2. All right, so this is what we are having. Make sure that the numbers are in line from the end. All right, the numbers should be in line from what? From the end. So now we can add. So this one, it simply means the what? There's a 0 there. All right, just place a 0 as a placeholder there. All right, let us add 1 plus 1, that is a 2. So the 2 that we are obtaining is the same as the base. So it is impossible for us to write 2 in the base of 2 because we are in base of what? We are in base of 2. So this is impossible for us to write this 2. So what are we going to do? Since the number is equal to the base, we divide by the base. The number divide by the base. So this 2 is the base, this one. So if we divide 2 divided by 2, that is going to be 1. We obtain a remainder of what? A remainder of 0. So like I said, the remainder is the one that you write on your answer. Our answer, that is the remainder there, which is the remainder. It's what? It's 0. In the base of what? In the base of 2. What about this one? We carry it to the next terms. All right, to the next numbers that you are given, we are going to add 1 plus 1 plus 1, which is a 3. But 3 is bigger than this base. So it's impossible for us to write the answer 3. We have to divide by the base. 2 into 3, that is going to be 1. Remainder what? Remainder 1. So the remainder is the one that you're going to write on your answer. We've got a remainder there. What about this one? We carry it to the next numbers that you're given. So it's now 1 plus a 0 plus a 0, which is a 1. Can we write this one in the base of 2? Yes, it's possible because it's less than the base. So this one, we are going to write it. We are not going to divide anything. We only divide by the base, provided that the number is greater than or it is equal to the base. So on this condition, there's nothing that we are going to do. Just write your 1. All right, we move on. 1 plus 1, we are back to that 2. Remember, we got a 2 and we said 2 divided by 2. That's 1. Remainder is 0. Remainder on our answer. What about this one? We carry it to the next term. 1 plus 1 plus a 0. Again, it's a 2. We do the same thing. We are not going to repeat this. We have already divided here. 1 remainder 0. So you know that the remainder there is what? The remainder is a 0. What about this one? We carry it to the next term. There is nothing that is there here. So we are going to add a 1. Then here it means we've got a 0 there. So that's 1 plus a 0, which is what? Which is a 1. 1 is less than the base. So it means we can write this 1 in the base of what? In the base of 2. So that is the concept of your addition. Whether you are in the base of 7, you are in the base of 8, you're in whatever base that you're given. So I want you to try as many questions as you can. There are so many questions here that you can try. I'm just going to work with you the part of J, this one, where we are given. So the part J, we are given 71247 in the base of what? In the base of 9 plus we are adding 60358 in the base of what? In the base of 9. All right, so we have to add our numbers first. All right, so if we add these numbers, we are in the base of 9. So if we add 7 plus 8, that is going to give us a 15. All right, so if we add this, is going to give us a 15. 15 is more than, bigger than the base. So what do? We divide by this base that we are given, which is the base of what? The base of 9. So 15 divided by 9 is going to be what? 15 into 9, that is 1. And we've got a remainder there of what? A remainder of 6. All right, that's 15 minus 9, which is a 6. So the remainder is the one that you are going to write on your answer. In the base of what? In the base of 9. Take note. What about this one? We carry it to the next term. We add 1 plus 4, which is a 5, plus a 5, which is a 10. 10 is more than the base, which is the base of 9. So you have to divide by 9. That is 1, remainder 1. So the remainder on our answer, this is our remainder 1. What about this one? We carry it to the next term. We add again 1 plus 2, which is 3, plus 3, which is 6. So 6 is less than the base. So we can write this 6 on our answer. We are not going to divide anything because it is less than the base. The same thing, 1 plus 1, that's a 1. It is less than the base. We just have to write it. 7 plus a 6, what are we going to have? That is going to give us what? A 13. So if we add 7 plus 6, that will be a 13. 13 is more than 9, which is our base. So on this condition, we have to divide 13 divided by 9. So that's 1, and we've got a remainder of what? A remainder of 4. So the remainder is the one that you're going to write on our answer. What about this one? We carry it to the next term. As you can see, there's nothing that is corresponding here. So we're just going to add here a 1, and there it's a 0. So that's 1 plus a 0, which is what? Which is a 1. So this is what you're going to have in the base of what? In the base of 9. So as you are to check, all these numbers that we are having here that are in base of 9, if you check all of these numbers, they are less than the base, which is the base of what? The base of 9. So in whatever case that you are to simplify and you obtain something that is greater than or equal to that base, it means your answer is totally wrong. Your answer is supposed to have numbers that are less than the base. So it is something that you can also put into consideration as you are working your questions, that the numbers that I'm supposed to have, they are supposed to be less than the base. All right, so that is the condition that you're going to have on your addition. So you're going to see that it is the same thing with your subtraction, but just a little bit different in such a way that, remember, we are still on the case that the bases are supposed to be the same. All right, so if you check on number B, it's a subtraction there that we are having. On this part B, we are having a subtraction there. So if we are to consider this, we are given 3, 1, 2 in the base of 5. And we are subtracting 1, 3, 4. That is 1, 3, 4 in the base of 5. So what are we going to do this time for a subtraction? All right, so when you are subtracting the number bases, please take note about this part. All right, if you were to subtract, just say normal numbers, 2 minus 3, it's impossible. That was the original way. We're saying it's impossible, yet now we are saying it's minus 1, which is fine. But on the number basis, we are not having that concept of 2 minus this in the base of 5, then it's going to be a minus 2. No. This is not the case. How do we subtract when the number that we are subtracting is bigger than? We are subtracting 4 from a 2. That's 2 minus a 4, which is impossible for us to do that. So what are we going to do? All right, on this condition, you add the base. Remember, we are in the base of 5. So you are going to add on this number here, we are going to add the base. So it was a 2, we add the base. So that's 5 plus 2, which gives us what? A 7. Then in this, on this one, we are going to give a 1. This one, you give a 1. So that's 3 plus 1, which becomes what? Which becomes a 4. So we are going to subtract 7 minus 4, which is 3 in the base of what? In the base of 5. So we are having 3 in the base of 5. The same thing or the same concept, 1 minus a 4. It's impossible for us to subtract. So what are we going to do? We are going to add the base, take note. So if we add a 5 here, this is going to be a 6. We give a 1 here, that's a 2. 1 plus 1, that's a 2. So we can subtract 6 minus 4, which is a 2. 3 minus 2, it's possible. So there's no need for us to add any base here because it's possible for us to subtract here. 3 minus 2, that's what? That's a 1. In the base of what? In the base of 5. So our answer is going to be 1, 2, 3, base of 5. So this is how you can perform your subtraction. If you check, that is the same concept on F. We are considering the same thing on this part F. That is where we are given 1, 0, 1, 2 in the base of 3 like this. What are we subtracting? That's 2, 2, 1 base 3. So it's going to be 1, 2, 2 like this in the base of what? In the base of 3. All right, let's subtract. So the first part, that's 2 minus 1. Is it possible? 2 minus 1 is possible. That's 2 minus 1, it's a 1. We in the base of what? In the base of 3. All right, we move on. 1 minus 2. It's impossible for us to subtract. So what are we going to do? We are going to add the base on this number here, which is a 1. We add our base, which is 3. So that's 3 plus 1. We've got a 4. What about here? We give a 1. So that is going to be a 3. So let's subtract 4 minus 2. That is going to be a 2. 0 minus 3. It's impossible for us to subtract. So what are we going to do? Give the base, add the base. So we add the base here, 0 plus 3. That's a 3. And we give a 1 on the next term. So now we have got 3 minus a 3. What are we obtaining? That's a 0 there. 1 minus a 1. That's a 0 again. So meaning to say at the end, our answer is going to be what? 2, 1 in the base of 3. These zeros that are before the number, they are not important. They are not important. So this is how you're going to perform your subtraction. So like I said, there are so many questions that I want you to try here. You try exercise 1I3. I want you to work out the other remaining questions. Let us know about the questions that are challenging so that we work on them, or we can have a revision on those questions. But as you can see, I think that will be a little bit easier from what we have. Then we've got the condition. Remember, I was saying that the bases are supposed to be the same. But if we check what we are having here, we are having a condition where the bases are now different. The bases are now different. Take note. We are having a number in base of 10, a number in base of 5, and the answer is needed in the base of 5. Take note. So there are two ways that you can consider. It's either you are going to express on this because you're already given in base of 5, in base of 8, in base of 3, in base of whatever that you're given. You're given where and how to express your answer. Are you going to have it in base of 5? Are you going to have it in base of 8? So it's either you are going to add or subtract the numbers in base 10. It's either you're going to add or subtract the given numbers, the numbers in base of 10. The numbers in base of 10. Why? It is easier for us to work with the base of 10. This is the normal base. Remember, base 10, that is the base that we are used to. 1 plus 1 is 2, 3 plus 3. Whatever that you add, there's no need for you to add this or subtract this. So meaning to say you have converted your numbers to be in base of 10, whatever condition that you have, you are now converting everything to base 10. You add those numbers in the base of 10. Then finally, you have to convert your answer to the given base. Convert the answer to the given base. All right, convert the answer to the given base. To the given base. That is how we can have it. Or what can we do? Instead of us writing these numbers in base of 10, we can simply work out the given questions in the given base. We are supposed to have it in base of 4, in base of 6. We can add these numbers in the base of 6 or in the base of 10 or in the base of 8. So meaning to say you convert the given numbers to the required base. So that is the first thing that you can do. You have to convert the given numbers, convert the given numbers to the required base. To the required base. That is, the required base can be the base of 8, can be the base of 4, can be the base of 6. That is the required base. So after converting to the required base, then you add or subtract. Add or subtract. That is the condition. Because you're already in the base of 4. You're already in the base of 2 where the answer is needed. The answer is needed in the base of 2. So you can add or subtract them. So it's up to you now to choose which of these two methods is easier for you. One of these, there's a condition where there is a benefit of you having in base of 10 and a benefit of you having the numbers in that given base. Like for an example that here, if you check, this is already in base of 5. So it means we only have to convert this to base 5 because the answer is needed in base of 5. All right? But on a condition like this, these numbers, all of these numbers, this is in base of 3, this is in base of 4. But the answer is needed in base of 5. So meaning to say there's a lot of conversion to be made in order for us to be in base of 5. A lot of conversion there. So what is the easier way? You will find out to just write these numbers in base of 10 is easier. I work them in base of 10. Then finally, I convert to the required base, to the given base, which is to the required base, the one that the person is asking you to. All right, so let's see. We are going to work out these examples and see what exactly we can do. All right, the first one, it was 333 in base of 10. So that's 333 in base of 10 plus the other one, it was 3 base 5, and the answer is needed in base of 5. In base of what? In the base of 5. Take note. So like I was saying, we can convert our numbers to the base of 10, then add or subtract. Here we are adding. Then we convert our answer to the base that is required, the base of 5. All right, then let us work with that one first. Our first method. So meaning to say to the base of 10, this is already in base of 10. All right, convert to base 10. Convert to base 10. All right, so to base 10, this is already in base of 10. We already have 3 in base of 10. What about 3 base 5 in base of 10? 3 base 5 in base of 10. Remember, that is where we said we raise. To remove in any base, we raise to the exponents of the given base. 5 to the power of 0 here, 5 to the power of 1 here. So this means we've got 3 times 5. All right, that is 3 times 5 to the power of what? To the power of 1 plus 3 times 5 to the power of 0. That is what we have there. So 3 times 5 to the power of 1, 5 to the power of 1, that is 5. 5 times 3, which is 15, plus 5 to the power of 0 is what? That's a 1. Remember, any number to the power of 0 is a 1. So 1 times 3 is going to give us what? A 3. Then we add, we've got what? 18. So meaning to say this number in the base of 10 is 18. So we have converted our numbers to be in base of 10 because it's easier for us to work in the base of 10. Already this was in base of 10. So we are simply adding 333 plus 18 in base of 10 because this is what we got from this one. 1/8 in base of 2, which is 18. These are no base 10. This is what we are using. Base 10, those are the numbers. 6 plus 1 is 11. 8 plus 8 is 6. Those are the numbers in base 10. The numbers that we are used to. So we just add 3 plus 8, which is 11. Remember, we write 1 and 1 here. 3, 4 plus 1, which is 5. All right, 3 plus a 0 here, that's a 3. So we are obtaining 351, which is in what? Which is in base of 10. Remember, not writing the base, it means you are in base of 10. But this is not where our answer is required to be. The answer is required to be in base of 5, not base of 10. So do not forget now that you are the one way to convert these numbers to base 10. So you are supposed to convert them back where? To the required base, to base 5. So finally, convert to the required base. So finally, convert to the required base. To the required base. And what is the required base? The required base is the one that you are given here, to base 5. We got, this is our answer now in base of 10. So you have to convert this to the base of 5. Remember, that is where we talked about this, guys. That's where we had the introduction. So if you did not watch that introduction, make sure you watch that because we talked about converting numbers from base 10 to any base. So how do we convert 351 to the base of 5? Remember, I said you divide by the given base throughout, noting the remainders down. So we are going to divide by what? By the base, where we are converting to the base of 5. To the base, the required base is the base of what? The base of 5. All right, so let's convert to the required base and see what you're going to have. 35 divided by 5, that is 7. All right, 1 divided by 5, that's a 0 there, remainder 1. We divide again by 5, 7 divided by 5, that is 1, remainder what? The remainder 2. Into 20, that is a 4, remainder a 0. 5 into 14, that is going to be into 10, 2 times, remainder a 4. 5 into 2, that is a 0, remainder that 2. So the answer from the bottom going up is going to be 2, 4, 0, 1 in the base of what? In the base of 5. Remember, I said you take your answers from the bottom going up. From the bottom going up. This is how you present your answers. Finally, our answer is in what? Is in base of 5. All right. But like I said, this is not the only way. We have also this consideration where we have to convert the given numbers to the required base, then add or subtract. What is the required base first? Convert the numbers to that base. Meaning to say on these 3, or okay, let's just work it out here so that we can see if can win 3 base of 10 plus 3 base 5. Remember, it was in base of 5. They want the answer to be in base of 5. We have the answer here from this method where we are to convert our numbers to be what? To be in base of 10. This is what we have to convert this to be in base of 10. Then we add the numbers in base because we are used to base 10. After that, we combine, we change now to the required base. So we want to see if we're going to have the same answer. By which method now? By this method of converting the numbers to the required. Just convert to the required base first. Convert to the required base. And what is the required base in this case? The required base is the one that we are given in the base of 5. Our answers are supposed to be in the base of 5. The answer is supposed to be in the base of 5. All right. So if we take this already, it is in the base of 5 already. 3 is already in the base of 5. So we are not going to change anything there on this 3 base of 5. There's nothing that we are going to change there. Okay? It's already in the required base. What is not in the required base is the 333, which is in base of 10. Remember, from our introduction, the conversion of bases from one base to another, we said we can convert from base 10 to any base by dividing by that base. So we have to convert to the required base, the required, which is base 5. So let's divide. By what? By 5, noting the remainders down. All right. 33 divided by 5, that is 6 into 30. We've got a remainder of 3. 33 divided by 5, that's 6 again, a remainder of 3. By 5 again, 5 into 6, that is 1, remainder 1. 5 into 16, that is 3 into 15, a remainder of 1. 5 into 13, 2 times into 10, a remainder of 3. 5 into 2, that is a 0, remainder what? Remainder a 2. From the bottom going upwards, our answer in the base of 2 is going to be given as what? That is going to be 2, 3, 1, 3 in the base of what? In the base of 5. In the base of 5 as we are going up. So we have the number now in the base of 5. Already this one, the second number here was already in the base of what? In the base of 5, this one. So now we can add these numbers in base of 5. All right. So the first one, we converted this to base 5. We got 2, 3, 1, 3, base 5. Plus what already we were given in that is what the question simply means. It simply means this here, because we've converted, it means this is now this one. But it was being added to what? It was being added to 3 base 5. Which is already in the base of 5. Remember, you can only add or subtract the bases that are the same. You can only add or subtract if the bases are the same. So what does it mean? It means now we can be able to perform our addition. So this is going to give us what? 2, 3, 1, 3 in the base of 5 plus 3, 3 in the base of 5. Remember the numbers from the end. So all these are zeros. Here there's a 0 here, there's a 0 there. So let's add 3 plus 3. Remember, guys, that's where we talked about this addition. We said if we add 3 plus 3, get a 6, it is more than the base. What do? You divide by the base. So 5 into 6, 1, remainder 1. Make sure that you have a recap. If you've forgotten this, that was our introduction of this class. So make sure that you have a recap. All right, the remainder is 1. We add the remainder there. 1 plus 2, which is 1 plus 1, sorry, which is a 2, plus a 3, which is a 5. 5 is equal to the base. It's impossible for us to write a number equal to the base. So we divide by the base. So that is 5 into 5, 1, remainder what? Remainder 0. The remainder on our answer, the 1 we give it to the next terms. 1 plus 3, that is a 4, plus a 0, that's a 4. It is less than the base of 5. So it means we are going to write that 4. It is less than the base. We only divide if the number is bigger than the base. 2 plus 3, 2 plus a 0 there, that's a 2. In the base of what? In the base of 5. So this is going to be 2, 4, 0, 1 in base of 5. So these are the stages that you can make or that you can take. So I don't know, it's up to you. Which method are you going to take? But as you can see, we are obtaining the same thing. Are you going to convert your numbers, all right, like this? Are you going to have your numbers in the base of 10? All right, are you going to have your numbers in the base of 10? Then finally you convert to the required base? Or are you going to make sure that in the first place, the numbers are already converted to the required base, so that you can simply now add or subtract? If it was a subtraction, we're going to subtract. If it was addition, you add. So this one, we're not going to say addition. It's just one and the same thing for subtraction. You're going to subtract, but the methods are the same. Are you going to work it through the base of 10? Or are you going to work it through that required base? So it's up to you. Which method are you going to pick? All right, so we're not going to waste much time. There are so many questions to attempt. I want you to try and work out as many questions. But when the bases are totally different, guys, convert to base 10. I think that is the easiest way. The moment you are not having a base of 10, like here we do not have base 10. For you to convert this to base 10, to base 3, you pass through the base of 10. You remember, you have to pass through base 10. So just convert your numbers to base of 10. It's the easier way. All right, you add your numbers there, you subtract. All right, let's see. This is what I'm trying to say on this G. 3, 2, 1 base of 4 plus 1, 2 in base of 3. Remember, in order for you to convert this to be in base of 3, because the answer is needed in base of 3. In order for you to convert this to the base of 3, we pass through base 10. We have to pass through base 10 first. Then we convert to base 3. Remember, those are the steps. So if I know that I'm going to pass through base 10, then base 3, let me just end there in base 10 and convert this also to base 10. Yes, I can do that, write it in base 3. I'm not saying it's wrong. No, I'm not saying it's wrong. You can work it that in base of what? In base of 2. In base of 3, I mean. So I want you to try it, but I'm going to do this in base of 10. Then you are going to do it in base of what? In base of 3, so that we see if we are obtaining the same thing. All right, so in base of 10, so in this case, I'm going to convert the numbers, to base 10. Convert the numbers to base 10. All right, so to base 10, that means we've got 4 to the exponent of 0 here, 4 to the exponent of 1, 4 to the exponent of 2. Remember your conversion, guys. This one we talked about this conversion. Make sure that you also watch introductions, all right? So this is 3 times 4 to the power of 2, this one, plus 2 times 4 to the power of 1, plus 1 times 4 to the power of 0. All right, so this is what we have. This is a single term, this one. So to show that this is just a single number, this one, I'm just going to open the mother bracket like this to show this one, it's a single number. That I'm going to add to this one that I'm converting also to the base of 10, because I said convert the numbers to base 10. So 3 to the power of 0, 3 to the power of 1. So let's convert to base 10. Remember here we are multiplying 1 times 3 to the power of 1 plus, here it's a 2, 2 times 3 to the power of a 0 like this. So this is what we are going to have at the end like this. So combine this, it's a single number, that one. Like I said, it's a single number. So that is going to be what? 4 squared, that is 4 times 4. Yeah, 4 squared, 4 times 4, which is 16 times 3, which is 48. Or you can just, let's confirm with our calculator here, but that is a 48. All right, so you can even simplify as much as you can. That is 3 times 4 squared, which is what? 48. So we've got 48 plus 4 to the exponent of 1, that is a 4. All right, so there we've got a 4 there. 4 times 2, which is 8, plus 4 to the power of 0 here, that's a 1. 1 times 1, which is a 1. All right, plus we do the same thing. Here, the power here is on 3. Here, the power is on 3, like this. 3 to the power of 1 is 3 times 1, which is 3, plus 3 to the power of 0, that's 1 times 2, which is a 2. So if we add everything, here, what are you going to have at the end? 48 plus 1, that is 49. This one gives us a 49 plus 8, that will be 57, 58. All right, that will be 58. All right, let's just be sure. Let us just have our calculator here, but that must be 58 or 57 there. Plus 8 plus 1. This will be 57, not 58, but 57. So we are having a 57 there, plus 3 plus 2, this one. Remember, it's a single term, which is a 5. So this is what we are having. We are adding this together, which is the one that gave us a 57. This together, which is the one that gave us what? A 5. Then we have to combine. Remember, we are in base of 10. Base of 10 is the one that we are used to. So we just add as usual. 57 plus 5 is what? It's 62. In base of 10. So that is in base of 10. But now the question is, our answer is supposed to be in what? In base of 3. In base 3. So we have to convert now our final answer to that base of 3, 62 to base 3. So this one we convert to base 3. Okay, so to base 3, what are we going to have? 62 to base 2 to base 3. That is 62. We divide throughout by 3, noting our remainders down. So let's divide by 3. 6 divided by 3, that is a 2. 2 divided by 3, that's a 0, remainder 2. Again by 3, 20 divided by 3, that is into 18. It's 6 times into 18, remainder 2. 3 into 6, that is 2, remainder a 0. 3 into 2, that's a 0. The remainder, that 2, it's impossible. So you have got a remainder of 2 there. So the answer in the base of 3 is going to be given as what? Remember, the answer taken from the bottom is going to be 2, 0, 2, 2 in the base of what? In base of 3. So this is going to be our final answer in the base of 3. So like I said, I want you to try these questions. All right. For this one that I've done, this one, G, try by working out in base of 3. Convert everything to base 3. Meaning to say we have to convert this to base 3 because already this is in base of 3. So you only have to convert this to base 3. then we add in the base of 3. So it's not like an addition only. It can be an also for subtraction, like I said before. It can be for subtraction. Is the one and the same thing. Let us just check one question on subtraction. We can also do this H. All right, we are given to simplify again in the base of what? In the base of 2. We are given 3, 5, 6, 7, minus 1, 0, 1 in base of 2. In base 2. So already this is in base of 2. So this time let us convert to the given base. Remember this one, we have to work it in base of 10. So for the advantage of, for the sake of revision, let us convert to the required base. What is the required base? Convert to the required base. To the required base. So the question is that, what is the required base? The required base is 2. The base of 2. So this must be in the base of 2. So how do we convert this? Remember, from base 7, from one base to another base, which is not base 10. The only way is to pass through base 10, then to the required base. So that is the only way. All right, which is the not like the only way, but we like I said, what is important is to know the actual way of doing it. That is the actual way of doing it. Yes, we can have our shortcuts, which is fine. So we have got 3, 5, 6 in the base of 7. So to the required base, which is to the base of 2, remember, that is the base of 2. This is our required base. We have to convert this first to the base of what? To the base of 10. How? Remember, to base of 10, we raise to the powers of the base, 7 to the power of 0, 7 to the power of 1, 7 to the power of 2. So we're going to write this as 3 times 7 to the power of 2. All right, plus we move on, we do the same here. 5 times 7 to the power of 1, plus we do the same thing here. 6 and 7, 6 times 7 to the power of 0, like this. So that's 7 squared, which is 49. Then 49 times 3, which would be something like having a 47 or 21 there. All right, let us see. 7 squared, 3 times 7 squared on our calculator. 3 times 7 squared. That will be 147. Yeah, there's a 7 there, 147. So we've got 147 plus 7 to the power of 1, which is 7. Then times a 5. 7 times 5, that is what? 35. Plus 7 to the power of 0, that's a 0, that's a 1. 1 times 6, which is a 6. Then we add these numbers, 147 plus 35 plus a 6. This will give us what? 188. Remember, we are converting where? To the base of 10. But our answer is supposed to be in the base of 2. Remember, we want to convert to the required base, which is the base of 2. Now we have converted this. It is now in base of 10. This number, the same number that we had, is the one that you see here in base of 10. But it must be in base of what? In base of 2. So how do we convert now from this base of 10 to base 2? To base 2. How? We divide by the base. So that's where we divide by the base. 188 in base of 10 divided by where we want to convert this 2 to the base of 2. So we divide by the base of 2. 18 divided by 2, that is 9. 8 divided by 2, which is a 4. Remainder what? A 0. By 2 again, 9 divided by 2, that is a 4. We've got a remainder of 1. 14 divided by a 2, that is a 7. Remainder of 0. By 2 again, 4 and 2, that is 2. 7 and 2, that is 3 into 6, a remainder of 1. 2 into 2, that is 1. 3 divided by 2, that is 1, remainder 1. 2 into 11, that is going to be 5, a remainder of what? A remainder of 1. The same thing, 2 into 5, 2, remainder of 1. 2 into 2, that is 1, remainder of 0. Then 2 into 1 is 0, remainder of 1. Okay, guys, we're having a bigger value there to consider. All right, let's just write our answer here. All right, so this is 1 from the bottom going up. So you're going to take this from the bottom up, 1, 0, and so on. 1, 0, This is 1, 1, 1, 1. 4 of them. 1, 1, 1, 1. Then 0, 0. That's 0, 0. The in base of 2. The required base is the base of what? Is the base of 2. In the base of 2. So we have our answer now. We are going to subtract. Remember, we are subtracting there. So we are going to subtract. What are we having? 1, 1. That's 1, 0, sorry. 1, 0 here. 1, 1, 1, 1. 0, 0. In the base of 2. Minus. What are we subtracting? 1, 0, 1 in the base of 2. So we are going to subtract this. That's it. We are subtracting. Now we are in the common base, the same base that the answer is required to be in. Now we can subtract. Remember our subtraction, 0 minus 1 is impossible. So what do? We add the base. Remember we talked about this. We add the base 2. We give a 1 here. 0 plus 1 is what? A 1. 2 minus a 1, which is a 1 in the base of 2. We do the same thing. 0 minus 1. It's impossible. What do? We add the base. On this 0, we add 2. That's a 2. We give a 1 here. That's now a 2. 2 minus a 1. That's a 1. 1 minus 2. It's impossible. So what do? We add the base, which is 2. Give the base here, which is 2. 1 plus 2, that is 3. And we give a 1 to the next term. So that's 3 minus 2. 3 minus 2, which is a 1. Take note. 3 minus 2, which is a 1. What about this? 1 minus a 1. That's a 0 there. Here, there's a 0 there. That's a 1. Here, there's a 0 there. That's a 1. Here, there's a 0 there. That's a 0. Here, there's a 0 there. That's a 1. So this is going to be our solution. This is going to be our answer at the end. So as we can see, whether it's an addition, whether it's a subtraction, the conversion part is the most important thing. Are you dealing with the required base? Are you dealing with the base of 10? That one, it's in your hands. So I want you to try as many questions as possible. Let us communicate on the comment section. Let me know about these areas, the questions that can be of challenge from this exercise. But as you can see from these basics, I think we can try as many questions. Yes, let's try to attempt as many questions. Then after that, do as many question papers, revise number bases from question papers. There are some questions which requires you to apply algebra, this and that. There are so many things that you need to understand. So revise your question papers after you've understood the basics like this. Go through the question papers and understand how do they ask the questions. That's it for now. From Maison African Motives, till we meet again.